Hi everybody, Patrick here from EngineeringShock.com, PaintballProps.com, and EscapeRoomElectronics.com. This is Project 12 and Project 13 for the Arduino Playbot. The Kickstarter campaign is linked below just in case you're interested. And for these two projects, we're going to use our light sensor, or our LDR. Now, for Project 12 and 13, we're just putting two lessons in one video because Project 12 is extremely simple. Now, LDRs are all different. This light-dependent resistor is in series with the 10k ohm resistor, and its resistance, the light-dependent resistor's resistance, changes based on how much light is hitting it. So, just for reference, I've written this quick program. All we need to do to set up for this program is add our jumper here, which I've already done. Change which forces our LCD backlight on. We've got our LCD's dip switch with all of them on, except for dip switch 1, which is turned off. And that enables our the communications between the Mega chip and the LCD. And as soon as I power it on, I'm going to zoom in on the LCD because I don't think you'll be able to see it very well. I'll zoom in just a second. But what it does is it reads the analog to digital representation of the voltage that is on the A2 pin, the analog pin 2. So right now it's reading 644, which is roughly 2.5. It's a little bit more. It's more like 3 volts. 1024 is 5 volts. 0 is 0 volts. We're reading 642 in this light. This is just normal indoor light. So let me zoom in on the light sensor and the LCD. That's the light sensor right there. And this is the LCD reading and updating every second. So if I take my hand and I'm going to place it over top of the light sensor, we're reading very close to 5 volts. So darkness is 5 volts. Now, what happens if I take my cell phone? I might end up interrupting the LCD here, or it might make it more difficult for you to see the LCD, but what I'm going to do is I'm going to turn on the torch to my phone, and I'm going to place it over top of the light sensor. And the voltage goes down to a digital value of 27, 29, which is very close to 0 volts. So using this code, we can look at our own light sensors because your Arduino Playbot might have come with a different light-dependent resistor. Light-dependent resistors typically have quite a large tolerance. So one LDR, even from the same batch, might react differently to the same light as another light-dependent resistor, which is why I want you to use this software when you receive your Arduino Playbot. And so you can understand normal light is roughly half the voltage, maybe slightly more than 2.5 volts, around 3 volts in this specific lighting, just normal indoor warm lighting. Very bright light will force the output of the light-dependent resistor circuit to the analog pin 2 to close to 5 volts, and a lot of light, darkness will do that, and a lot of light will force it down to roughly 0 volts. And that's because depending on the resistance of the light-dependent resistor, more or less voltage will be dropped along the 10k ohm resistor that is in series with it. Again, the schematic diagram for the Arduino Playbot will be released to those who purchase or pledge towards an Arduino Playbot in the Kickstarter. So now that we're able to see this, we know that, again, darkness is close to 5 volts, 1024. Lots of light is close to 0 volts, which is around 20 to 30. And right in the middle, we've got roughly 650. So by using this, we can move into project number 13, which I'll just continue on right now, and we're going to create a light sensor that triggers the relay. For project 13, the only thing we need to do is turn the relay on. The ROI dip switch, just turn it on. So for those of you who haven't been following along with the projects, I believe it was project number 3 or 4 where I create a clap on, clap off light, and for that we use the relay because the relay is a powerful switch. It's an on-off switch, and in that video I show you how to hook it up to an extension cord which acts to turn a lamp on and off. I'm not going to repeat that step here because if I did, every time I use the relay I'd have to reset that up, and I'm just not willing to do it because it's very clunky and very time consuming to do that. But the LCD here does the talking for us. So just listen for the LD. I'll zoom in on the LCD in just a second. Right now it says relay off, LDR val 644, 646. It keeps updating. So as soon as the LDR value goes over 800 or 800 to 1024, which is the max, that means that there's darkness hitting the LDR or enveloping the LDR. Relay on. LDR val equals 999. I'll remove my hand. LDR off. LDR val 643. So less than 800, relays off. More than 800, relays on. And you can hear the relay turn on. Again, it's a digitally controlled but isolated power switch, which can be connected to on this 3-pin terminal block. If you haven't watched the videos already, I highly suggest going back and watching each video separately. Each video has its own custom code that will be included with a pledge for the Arduino Playbot. So again, listen for the relay. On, and then it'll click off. So now we'll zoom in on the LCD. My camera does not like the LCD, but trust me, it looks beautiful to the human eye, easy to read. My camera just does not seem to care for it much. So I'll put my hand over the light sensor, relay on, and then it'll say the val. As soon as I expose the LDR to light again, the relay turns off. So we can use the relay to power AC or DC devices. This code is very simple, it's fully commented, and you can modify it as you see fit. You can change the numbers. It's very, very easy. It's a very simple, both of these projects are very, very simple programs. So if you haven't already, check out the Kickstarter link below. When I've created the final video for the Arduino Playbot, I'll make a list of videos that will be posted below in this video and every other Arduino Playbot project video. So thanks for watching, everyone. I hope you're having a great day.